This presentation illustrates the concept of early implant placement in the anterior maxilla. The implant will be inserted together with a simultaneous GBR procedure to regenerate a peri-implant bone defect. The patient is a 53-year-old female with a single tooth gap in the anterior maxilla. Tooth number 21 had to be extracted due to a long fracture of the root. The periapical radiograph shows the fractured tooth before it was removed. An early implant placement is planned following 8 weeks of soft tissue healing after extraction. The tooth was extracted without flap elevation to reduce tissue morbidity. 8 weeks following extraction, the radiograph demonstrates that the extraction socket of tooth 21 is still apparent. The clinical status confirms the healed soft tissues. The single tooth gap measures 9 millimeters mesiodistally. This gap is suitable for a Straumann implant with a standard neck configuration of 4.8 millimeters diameter. The mirror view shows that the soft tissue has healed well 8 weeks after tooth extraction. The tissue height is sufficient for an aesthetically pleasing outcome. The surgery is begun with a slightly palatal incision in the crestal area. The incision is extended through the sulcus to the facial aspects, where vertical releasing incisions are made at distal line angles of both adjacent teeth. The mucoperiosteal flap is carefully elevated with a fine Hugh-Freedy tissue elevator. A retraction suture in the flap ensures sufficient access to the extraction socket of the implant site. The extraction socket reveals partial bone fill and a favorable ridge contour with an intact facial bone plate. The periodontal probe indicates that there has been no significant facial flattening of the alveolar ridge since the tooth was extracted. The palatal flap is carefully mobilized to check that the palatal wall is intact. The width of the orofacial crest measures 6 millimeters in thickness, which is adequate for implant placement. Next, the granulation tissue is removed from the alveolus using a curette. The mirror view reflects a basically intact facial bone wall. After the implant has been inserted, a relatively small peri-implant bone defect is expected. It will be augmented using a simultaneous GBR procedure. The occlusal view reconfirms that no facial flattening has taken place since extraction. The preparation of the implant is begun by using a number 2 round burr in the palatal bone structure. This step makes it possible to correctly position the next drill, a 2.2 millimeter pilot drill. The surgeon uses his free forefinger to correctly position and stabilize the drill as he uses it. A 2.2 millimeter depth gauge is inserted to check the position and axis of the first preparation. The osteotomy is enlarged with a number 3 round burr, followed by the second pilot drill, which is 2.8 millimeters in diameter. It can be easily inserted and prepared to depth. The 2.8 millimeter depth gauge is placed using an inserted 5 millimeter ring, which represents the future implant shoulder. In this case, the implant position is good in the orofacial direction, with a distance to the periodontal probe of 1 millimeter. The frontal view in the mirror reveals that the mesiodistal position of the future implant is correct. There is sufficient space between the implant shoulder and adjacent root surfaces. A profile drill is used to further increase surgical access for the next largest spiral drill. Bone preparation is continued with the 3.5 millimeter spiral drill. The implant bed and its position are checked with the corresponding depth gauge. To complete bone preparation, a special TE profile drill is used to prepare the coronal aspect of the implant bed. The shoulder of the drill is positioned at the level of the facial bone wall. Again, soft tissue remnants are carefully removed with a curette. A Straumann TE implant is now slowly inserted to the correct depth using a contra-angle handpiece at a speed of 15 RPM. The mirror view shows the vertical position of the implant shoulder. The shoulder is positioned approximately 1 millimeter apical to the CEJ of the adjacent central incisor. The insertion device is now removed in a counterclockwise direction. The position of the TE implant is ideal for the CEJ of the adjacent teeth and the final alignment. The implant is well positioned in all three dimensions, and its primary stability is excellent. A 1.5 millimeter large healing cap is inserted to cover the implant shoulder. The small peri-implant bone defect is clearly visible. It will be grafted with autogenous bone chips. The goal is to build up the facial bone wall as support for the facial soft tissues. Autogenous bone chips are easily harvested with a flat chisel at the nasal spine. These fine chips are directly filled into the facial bone defect between the exposed implant surface and the thin bone wall. To achieve a tension-free wound closure, the periosteum is released with a blade. This incision causes spontaneous bleeding. The blood is collected with a syringe to mix it with bio-os granules. The mixture of bio-os and blood is easy to apply. Bio-os granules are used to over-augment the alveolar process, since they offer good volume stability due to the low substitution rate of bio-os. A resorbable BioGuide membrane is trimmed to the required shape using a pair of scissors. A trapezoidal strip is first cut. The membrane is held with a pair of tissue forceps to avoid contamination with the talcum powdered gloves. The membrane is placed over the grafted site and adapted to its surroundings. Once the membrane is soaked in blood, it becomes self-adhesive and stabilizes itself. A second membrane strip is cut and positioned on top of the first one. This improves the stability of both membranes even more. To complete the surgery, the flap is repositioned and sutured with interrupted single sutures. A primary tension-free wound closure is achieved using 5O polyamide suture material. First, 2 crestal sutures are placed, followed by numerous single sutures to close the releasing incisions. The mirror view shows that the soft tissue height in the single tooth gap is good. At the end of the surgical procedure, a pressure dressing is applied over the upper lip to control the swelling and to limit the risk of hematoma formation. After 8 weeks of healing, the clinical status demonstrates excellent soft tissues at the surgical site. The site is reopened using a small tissue punch fitted with a 12B blade. The healing cap is visible and removed with a screwdriver. A longer healing cap is inserted. It pushes the soft tissues in a facial direction. After the reopening, the prominent frenulum was also cut to improve the soft tissue aesthetics. The final view shows the transmucosal appearance of the implant and the frenectomy that was performed. This is the clinical status following incorporation of an acrylic temporary crown based on a titanium coping. This provisional crown is left in place for 3 months to condition the peri-implant soft tissues. The periapical radiograph shows a well-integrated TE implant with stable bone crest levels. The corresponding radiograph shows the TE implant with the ceramo metal crown. At the bone crest, the bone has adapted well to the screw-retained implant crown, reaching a steady state situation. The clinical status demonstrates the results 7 months after the implant placement. The detail view confirms a pleasing aesthetic result with a harmonious gingival margin, intact papillae, and healthy peri-implant soft tissues. The patient's smile confirms the attractive result. The clinical status 3 years later shows a pleasing aesthetic treatment outcome with a nicely scalloped gingival margin. The periapical radiograph demonstrates a well-integrated TE implant with stable bone crest levels.